Hi Kiran. Hello everyone.
Hello.
Good morning.
Hi there. Good morning.
Hi, good morning.
Good morning.
Good morning, sir.
Okay. So let's get started. So yesterday we have seen like all the components like channels, smart contracts, then chain codes. So all those things we have completed. So today we'll talk about the runtime architecture, how the runtime architecture will look like when you run Hyperledger Fabric network, and also like when you execute any kind of transactions, so how that transaction workflow will be there. So that we are going to discuss today. Okay.
Okay.
So yeah, Kiran, if you can allow screen sharing.
Yeah. It's allowed now.
Okay. So here we have the agenda. Okay. So first we'll discuss about the EOV approach. Okay. And then we have the SDK, that is Fabric SDK, basically to connect two systems. And then we'll look at runtime architecture, then event services and private data collections. So these are the topics which we are going to discuss now. And after this, we'll discuss about the transaction lifecycle. Okay. So the very first thing is EOV approach. Okay. So basically in the Hyperledger Fabric, the consensus is divided in three phases. Okay. So it is not like if you just do the endorsement, your consensus is completed. Okay. So especially in the Fabric, our consensus will be like it will start from the endorsement, ordering, and then validate. So I will discuss like how this individual process will be working. Okay.
Mhm.
The very first thing is endorsement, right? So endorsement meaning getting a kind of agreement on a particular transaction. Okay. So let's say we have some endorsers, peers in our organization, okay, or in our network. So the very first thing will happen in the Hyperledger Fabric is whenever a new transaction comes, okay, so that new transaction request will go as a proposal to the endorsing peers. That is the very first thing for every transactions. Okay, first the endorser peer will look at the request. Okay, they will verify the request. They will look at their own ledger. Okay, they will verify the read and they will verify the uh, transaction request which is correct or not. Let's say for an example, I'm transferring 100 rupees from person A to person B. So the very first thing what they will verify is, okay, whether this person A is there in the system or not. Secondly, if it is there in the system, then he has, or it has that much amount or not, the amount which they are transferring. These kind of values or this kind of validation will happen, and once that is done, they will create a read and write set. Okay, so read set meaning the current state, and write set meaning the next step which is going to come. If he is transferring some money, so then next step would be 100 would be minus from person A and it will be credited to person B. So that will be your right state, correct? So
Yeah.
that they will create and they will send again back to the SDK. Okay, after that, this is the complete endorsement process. Okay, here one concept will come like a endorsement policy also. Okay, so endorsement policy is like how many or how many minimum endorsement you need for a particular transaction. Okay, let's say I have a network where I have some three organizations, and in all three organizations, two peers are there. So total six peers are there, and three organizations, and one ordering organization is there. Okay. So now in the endorsement policy, what I have defined is I need at least one endorsement from each organization. Okay, one endorsement from org one. It can come from peer one or peer two. Any peer is fine. One from the organization two, one from organization three. Okay. So my system will wait. Okay, it has a timeout. my system will wait till that time. If it receives the all three endorsement, okay, then only it will again go to the next step. If for a particular time, if we don't get required number of endorsement, our transaction would be filled that time only. Okay, so here this how we will decide, okay, how many endorsement we need and how many from which organization. So that is defined, or that configuration is done by the endorsement policy. So in the endorsement policy can be defined in the and or format. Okay, so let's say you if you define and, let's say I need endorsement from all three organizations, so you will define org1 and org2 and org3, like this. And or operator, I know, like you must have seen how to use that also. You must have seen in the coding languages how we use this and or operators, right?
Yes.
So basically here also the same thing will apply. So we are going to use and or operator. So you can use single and also, single or also. Also you can use the combination of and or. Okay, so that is also possible. So let's say you need something like a you will define from org1 and org2, any one organization is fine, but org3 is mandatory. Okay, so you will define, okay, org1 or org2 and org3. Okay, so this is the one condition, or one way, right? So this is how we define the endorsement policy. That comes under the endorsement process only. Now, now my endorsement is done. Next phase will come is the order. Okay, so order meaning when we receive the endorsements, after that your ordering service come into the picture. Ordering service will validate all your transactions. Okay, it will validate the endorsements. How many endorsement you got, that validation will be done. The endorsements are correct or not, that is also being verified by the orderer. Once that is done, then your order will arrange your transactions on the basis of time, and then it will create a new block for our Hyperledger Fabric network. Okay, once the new block has been created, that block can be, or that those transactions can be again broadcast to the next level. Okay, but the ordering system job is to create a block, arrange those transactions, okay, with the time stamp or with the timely manner, and then put inside a particular block. Okay, and after that it will broadcast to the leader peers of the organizations. Okay, so now after the broadcasting, what will happen is validate will come. Okay, so validate meaning when a transaction or when a block will come to the committing peers, that time the validation will be happening. Okay, so validation meaning like it is not a straightforward transaction is coming or a block is coming from the order, it is 100% correct. Okay, so to make sure or to cross check again, the peers who are going to commit that change or who are going to commit that block inside their ledger, they are going to do the verification validation. Now what kind of validation will be happening? So here they will validate, okay, how many endorsement we got for a particular transaction, the who has endorsed that transaction, the peer who has endorsed the transaction, he has a valid identity or not, he is part of MSP or not. Okay, will be verified here, then only uh, they will commit the change into their ledger. Okay, so yesterday, if you remember, I was showing you one let me open it. So yesterday, how a block looks inside, like inside a block, how it will look, and a transaction. Okay, so let me open that. I will try to explain you how, like what kind of validation will happen at the end. Okay, so You can see here, this is the block structure.
Yeah.
Okay. So as you know, like if you see here, you have the block header. This is every blockchain will have this block header, right? It will have the block number, previous hash, and data hash. Correct. This is common for all the blockchain. Then at the last, you will find block metadata. So in the block metadata here, this is the different. Here we will have the creator identity. Okay, who has created this block? So obviously order will create, correct?
Mm-hmm.
Then last configuration block, creator identity. Okay, so last configuration block, like a last block who has created that, his identity. Then last offset persisted, if any Kafka things are there, so that will thing will come. And here you can see signatures are mentioned here,
Yeah.
right?
Yes.
So it meaning that whoever is going to create a block, his signature will be there. Okay, so every block will be or every task which is happening inside the Hyperledger Fabric, that task will be signed by a particular person who is doing that. Okay, to make sure it is done by the proper, or it is done by the correct authority or not. Okay, so this information will be validated at the commitment. Okay, so when because as you know, like we are, if we are in the network, so everyone will have their public key and private key, right? So whenever a signature you see, that time that signature is done by the private key. And as you know, in the blockchain or in the cryptography, basically, uh, public key and private key comes in a pair, right? So if a particular document or a particular transaction is signed by the private key, it can be validated by public key, correct?
Mm-hmm.
So here whatever things are signed by a private key of order, of peer, or of anything. Okay, so at the end it can be validated by the committing peer. How? Because everyone knows the public key of everyone. Okay, so public keys are visible to everyone. If someone wants to validate a particular transaction, whether it is signed by a correct authority or not, they can validate with the help of public key. Okay, this point is clear, right?
Yeah.
Now just look at this particular let me, from here to here. Okay, so the very first thing here is transaction proposal, endorsement, and proposal response. Okay, so basically three major things are there, and these three things are part of the endorsement process. Okay, so every transaction will have this information. Okay, this is the green one, if you see here. So the very first thing is, look, so how a transaction proposal will come. Okay, so transaction proposal will have these many fields. It will have transaction type, version, timestamp, channel ID, transaction ID, epoch, payload visibility, chain code path, chain code name, version, who has created, right? So let's say it is coming from a particular person. So client identity will come, his certificates will come, then signature. So the one who is creating that transaction proposal, his signature will come. Then chain code type, okay. Then input, like you what is your chain code function and the arguments which you want to pass. And at the last, you will find the timeout. Okay, so this proposal has a timeout, like after this time it will be invalid. Right, so this is the transaction proposal which will come at the time of endorsement from the client. Okay, so here my only point is how you are going to validate, the request, or how you are going to validate the transaction at the end, at the time of commitment.
Okay.
Okay, now it may not be 100% clear, like how this transition proposal and where exactly it will come. So don't worry, that will come when we discuss about the complete transaction life cycle. Okay, so that is there in the next slide. So just
In
hold on
short,
for that.
this is the
Hmm.
overall block structure of any
Huh.
transaction that happens
Any transaction
on
that happens.
Hyperledger.
Yes,
Okay.
yes. So so now endorsement, order, and validate. So this will happen for every transaction, okay, which is happening on the channel. Every transaction will have this phase. Okay.
Mhm.
Now coming to the next part, that is the SDK. Okay, so the very first thing is what is the SDK here? So SDK is nothing but the high level code or low level code which is provided by the Hyperledger Fabric. Okay, so basically what happens is uh, we are creating a network that is a backend network, correct?
Mhm.
That is the because that is running on the backend, and but ultimately your users, your customers is going to use a good looking mobile application, a good dashboard where they can place a request, right? Just like any other applications also, like if you use mobile applications, so in mobile application you will have the good looking UI from where you can just place your request or whatever interface you want to use, correct? Similar way here also, like if you are creating the D apps, basically a client application should be there, right? But the problem is how your client application will connect to the Hyperledger Fabric network. Okay, so
Right.
to stabilize that connection, to make that connection, okay, we have the SDK. So SDK is software development kit. So
Mhm.
Java SDK you must have seen.
Mhm.
.NET SDKs comes, right, and Android SDK is there. iOS SDKs are there. So basically, in the SDK, some pre-written functions and the methods will be there, which you can utilize to write your own APIs. Okay, so basically, let's say you want to register a new user, okay, and the request which is coming from the client, that can be in any format, okay, but your network doesn't understand that format. So the SDK will convert the request into the correct format which is understandable by the Hyperledger Fabric network. Okay, so that conversion, that proper request management will be done by the SDK. Okay, right now we have two available SDKs. So we have Node SDK and the Java SDK. So two language SDKs are available right now. So Node SDKs are like widely used, but of course Java is also like a legacy applications are built on Java only. So that is why they have developed the Java SDK also. Okay, mostly like functions are same. The task which can formed by the SDK both are same. Okay, only the language is different. That's it. Okay,
Yeah.
now what kind of work we can be done by the SDK? Okay, what we can do with the help of SDKs? So SDKs can be used for creating a channel. Okay, so you can create with the help a channel with the help of SDK. Requesting peers to join channel, you can ask peer, you can send the request to join the channel. Installing the chain code, instantiating the chain code, okay, then invoking the transactions and query the ledger. So basically last three, if you see, invoke, query, and rich queries, these are the functions which is being used, let's say, 1,000 times, okay, in your applications. Only the creating channel, requesting peer, these are the this first four are the one time setup, okay, because you are creating a channel only one time, right? Rarely you will create a second channel, third channel, fourth channel, right?
Mhm.
And that can be done by admin also from the backend. Okay, so for that SDK function you really need to write, that is not actually required. Okay, same change is requesting peer to join channel and installing and instantiating the chain code. Okay, so these things are like a not frequently used. Okay, so that is why like to write a function for that, it is not 100% necessary. But invoke, query, and rich queries, for these, of course, the SDK functions will help a lot, because
all the time you cannot send a transaction from the command line, right? You have to write
Right.
something, some system which can automatically accept the invoke transaction, query the transactions, perform some rich queries on your database, right?
Mm-hmm.
So that is the main function which we are going to see in the action. Okay.
Yep.
So next we have the documentation. Okay, so basically four main modules you will find, uh, especially for the Node SDK. So I majorly worked on Node SDKs only because Java I don't know, and so I will explain you with the help of Node SDK only. Okay,
Mm-hmm.
what kind of functions, what kind of classes are there, what kind of interfaces are there. Okay, so majorly, as you know, like Node works on the modules, right? So majorly you will find four modules, uh, Fabric CA client and Fabric network. Okay, so when you install the Fabric CA client and Fabric network, only two major modules will come into your will be installed in your system, and common and portos that will come by default along with the network. Okay, so we don't need to like separately install those common and portos. So now the main thing which I just give you here is we have the complete documentation of SDK. Okay, so here this is the documentation of Node SDK. Okay, so Node SDK is having two versions. One is 2.2, second one is 1.4. So 2.2 we have, that is the latest version, and the secured one which is introduced after 2.x Fabric version, and 1.4 is the old version which is less secure and which has uh, some serious issues. Okay, so that is why they have rebuilt everything and they have launched a new version also. But if, because few organizations they are still using the 1.4 also, that is why they're still supporting the 1.4. But uh, if we are starting now, then we should start with the 2.2 version only.
Mm-hmm.
Okay,
And it is not possible to upgrade from 1.4
it is
to
possible,
2.2.
it is possible,
Mm-hmm.
it is possible. So it is not completely different. Yeah,
Mm-hmm.
few methods they have created new, few
Okay.
security things like uh, earlier what was happening is all the commands was given to the SDKs only. Okay,
Mm-hmm.
like you can manage complete network from the SDK, but that should not be the case, right? Because
Mm-hmm.
someone is hacking your SDK, then he can do anything, right? And so that is why they have removed some of the functions which are not necessary to have in the SDK, that can be done by only admin from the backend, from the command line, and only few things which is like 100% necessary, those are in the 2.2. So 2.2 is like a more secure and performance is very good. Okay, so the performance wise 1.4 was very bad because every time you have to, like, it is like one server you have to run, uh, like one separate server you have to run in the 1.4, then only it will work. One node.js server you have to create and then it will run. But here in that is not the case. Directly we can run, directly you can execute. So that is one thing which we have. We'll see how it is there and what kind of functions are there. Okay, how you can install the Fabric network? Simply npm install Fabric network. So your packages will be installed in your system. If you know Node.js or if you know the JavaScript, you will easily understand what npm install will do, right?
Mm-hmm.
So now we have the complete documentation here. So this is the documentation for Fabric network. It has the module, so only one module, Fabric network. Then we have the classes. So these are the classes which are available. Okay, so we are not going to use all the classes, but yeah, of course few classes are there, like for channel, client, commit, then for discovery, event services, then identity management, right? So these are the classes which we are going to use, and some interfaces which we are going to use. So interfaces are available here. So contract interface or identity interface, network interface, query handler. So these are the interfaces which we are going to use in our network. Okay, all of them we may not be using, but some common interfaces and classes are there, which we are going to use in our system or in our network. Okay.
Yeah.
So here, the very first thing whenever you want to connect to the network, okay. So here the very first thing what we have to do is we have to create a gateway. Okay. So basically a gateway is a secured communication medium or a secured communication way which will connect uh, your middleware to the fabric network. Okay. So basically if you guys know about MongoDB, right? In MongoDB, we create connections, right, to the database, or in SQL Server also we create. First, we have to establish the connection, then only we can send the database request. Correct. So same way here also we are going to first create a gateway. That gateway will allow us like one. It is like a you can have multiple gateways also. Okay. Let's say for each transaction you are going to create a new gateway. Okay. And you can have a single gateway also. You can live, like you can make, okay, so let's say 2 minutes timeout is there. So in every 2 minutes your gateway will be disconnect and connect again. Okay, to just make sure the security. And in that 2 minutes you can send n number of requests, right? You can run as a infinite also, like you can just connect your gateway once and then it will be connected until you stop your network. Okay, so that is also possible. Okay. After that yeah, that this point this classes will have the complete discussion when we are going to use this. So that time it will be very useful also, because right now there is no concept, only you will find the syntax. Okay, so syntax is useful when you write something, right? So we'll discuss that time only. So next we have, so this is clear, right? No, the SDK. Similarly, we
Yes,
have
yes.
the Java SDKs also. Okay. Now moving to the next part, that is runtime architecture. So this is the runtime architecture of the Fabric. Okay. Just look at this and let me know if something is familiar, something which I was explaining and which is available here.
Yeah, so flow is making sense. The SDK will flow to the orderers and then orderers to the peers, and then through the SDK, the validation verification will happen.
Yeah. So like majorly the components are very clear. SDKs, we know what kind of SDKs we have. Membership, like from where your certificates will come. Orders, like who is going to create your block, and peers who are going to host your ledger, and the chain code, right? And now the flow, how it will come. So SDK will have the identity provider interface, which is coming from the membership. Okay. So SDK by default, it will not have any kind of certificates, right? How it will have. So basically it will get from the membership, like what is the identity of peers, how many peers are there, how many organizations are there in the network. So that information will come from the membership. And then SDK will first send a proposal. So step number one, if you see, this is the very first. So this is a proposal, right? Proposal, if you recall here, if you come here, this is my proposal, transaction proposal. So in the proposal request from the SDK, this information will come. This information. Okay, this is the transaction proposal. After that, the next step is, it will come here. It will come to endorsers first.
Okay. In the endorser, what endorsers will be doing is they will be doing the endorsement. Okay. So if they are doing the endorsement, and then that endorsement response will go back to the SDK. So if you come here again, so here, this is your endorsement. So in the endorsement, this information will be available. So endorser one, like how many endorsement has been done. So if you have, let's say, 5 endorsers, so endorser one identity will be there, his signature. Endorsers two identity, his signature. Likewise, 3, 4, 5, whatever number you have. Okay. After that, the response. So proposal response will send back from the endorsers to the SDK. So in that proposal hash, okay, chain code events, response status, namespace, read set, okay, and write set. Then start key, end key, list of keys, and Merkle tree query summary. This is the information which will be going back to the SDK as a response. Clear?
Yes.
So here your endorsement has been completed. Now that response will again go back to the SDK. SDK will collect all the endorsements. Okay. So it is not necessary like every endorsement is coming within a second. Some endorsement can take 2 seconds, 3 seconds also. Okay, so that is fine. So it will SDK will collect all the endorsements, then it will submit those endorsements to the ordering services as a transaction. Okay. Now ordering service will validate all these transaction responses. Who has signed the endorsement? How many endorsement we receive? Whether the endorsement policy is fulfilled or not. All this verification will be done by the orderer. Then orderer will arrange those transactions on the timely basis, and after that, it will create a block. Okay. Once it
Yes.
creates a block, that block will go for the delivery. So it will broadcast that block and the transactions to the committing peers. So here the committers are there, right? So committers are there. Now committer's job is to commit that block and the transaction. So remember one thing here, order will broadcast two things. One is the transaction state, that is world state, and block. So block is going to commit into the blockchain, and your state will be going to update it in the world state, right? Because we have two parts in the ledger. If you guys recall, we have two parts in the ledger: blockchain and the world state. Okay. So
Yes.
blocks will be committed to the main blockchain. Inside your block, your transactions will be there, but world state will be state would be committed to the world state. So basically, world state would be updated if the transaction is successful. Okay. Now let's say you got the required number of endorsement. Okay, but in the endorsement, the read write set are not correct. Okay, like you are not getting 51% majority in the read and write set. Let's say 5 endorsement you got, and in those 5 endorsement, some are like there is a tie. Okay, and 2 are like four endorsement is there. So 2 are saying like the transaction is valid, 2 are saying transaction is invalid. Okay, so in this situation, what is going to happen is our transaction will be invalid. Okay, so if the transaction is invalid, so it is not like it will fail at the order. Okay, what will happen is order will put a flag of invalid transactions. Okay, so now what will happen is your transaction will go inside the block as an invalid flag, and it will be committed to blockchain also. Okay, but your world state is not going to update. World state is only going to update when you have the successful transaction. When you have, sorry, not successful, when you have the valid transaction. Okay, So when you have the valid transaction, then only your world state would be updated. If you have invalid transaction, your world state is not going to update. But for the history, your transaction will be available inside the block. Later on, if you want to check it out, when this particular transaction was filed, you can just query that failed or invalid transaction from the main blockchain. Okay, so this is how the complete thing will be working. Complete architecture will look like. Clear?
Yes, yes, that's good. And
Okay.
guys, any issue? Any questions? Anirudh, Gayatri,
No, it's
Esther?
clear.
No, no, sir.
Okay.
Okay, perfect. So, okay, phases we have discussed. So total 4 phases you will find: proposal, endorsement, submit, and validation and commit. Right. So these 4 things we have just discussed. So first is proposal, where the proposal will come from the SDK. Then endorsers will provide the endorsement. Then it will submit to the SDK will submit to the order. Order will create the block. Then it will broadcast to the committers. Committers will do the validation, and then they will commit the block and the transactions into their ledger. So this is the complete phase. Now, next we have the private data collection. Okay. So till now, we have seen channels, right? So how we define the privacy levels? So we define the privacy levels with the help of channels, correct? So let's say if you want to do some transactions between organizations, so the best way is to create the channel between those organizations, and you can do the transactions, right? Now there are some requirements, okay, or some business need is there, like we are not going to create a separate channel, okay, but we want to create a still we want to do some private transactions between peers. Okay, let's say you have 3 organizations in the network, okay, and 3 organizations have two peers, peer 1, peer 2 for first organization, peer 1, peer 2 for second organization, peer 1, peer 2 for third organization. Okay, so total 3 organizations and 6 peers. Now let's say there is a requirement, org1 and org2, these 2 organizations peers, that is peer 1 from org1, peer 2 from org2. Only these 2 peers want to do some private or some confidential transactions. They don't want to expose the data to other peers in the channel, okay, or other organization in the channel. Also, they don't want to expose the data to the ordering system also, okay. In between only these 2 peers, the data should be available, or the data should be visible. So in this situation, what we can do is, the another option is creating a channel, right? But that channel is also on, like, you have to create between org1 and org2, right? But still your other peers from org1 and org2 will see the data, correct? Which but that we don't want. So in this situation, what we can do is, we have the concept of private data collection. So private data collection mostly work on the peer level. Channel works on the organization level. Private data works on the peer level. If you want to do some private data, or you want to do some private transactions only with few peers, you can have a private data collection created for those 2 peers, 3 peers, whatever number you have, okay, without creating a separate channel. Okay, on the same channel you can do the transactions, but those transactions will be visible only to those peers who are part of the private data. Other peers will not see that data, okay.
Right.
So that is the main objective of the private data collection. Now in the private data collection, we have 2 elements: the actual private data, that is the actual data, which will be in a byte format, and the hash of the data, hash of same data.
Mhm.
Okay. This is a 2 elements which we are going to have.
So actual private data will be visible or will be available to the peers who are part of the private data collection. The hash of the data will be available to everyone. Okay, like everyone meaning all the commenting peers who are part of that particular channel. Okay, because we are doing inside the channel only, right? So inside the channel, the actual data will be visible to only the peers who are part of the private data, but the hash of the data will be available to all the peers who are part of the channel. Why the hash of data should be there? Because of the auditing purpose, right? It should not be there. Okay, in silos they are doing whatever they want to do. No, they can do the transactions. The data will not be visible to others, but for the auditing purpose, what kind of how many transactions are there, that hash will be available to others also. As you know, like hash cannot be converted back, or cannot be, it is not vice versa, it is one way
One-way
activity.
encryption. Yeah.
Yes. So, or for auditing purpose, hash will be available to every peer. Okay, now let's see with the diagram. So how in the world state your data will be stored? Okay, so authorized peer meaning the peer which is part of your private data. Unauthorized peer meaning peer is not part of private data. Okay, both are part of, both are having access to channel one. Okay, and so one, we have the channel state. So in the channel state, all the transactions which is happening in the channel, that will be available. Okay, in the private state, you will have the complete data. Okay, so the thing which I was explaining here, the actual private data and the hash of that data. So the actual private data here, sorry, private data state meaning actual K1, but in the channel state, only hash of K1 will be available to everyone here and here. Clear, right?
Yes.
So this is how the data will be stored in the private data collection inside your world state. Okay, now the question comes when to use channel and when to use like collection. Okay, so these are the two conditions. So if you want to use a collection within a channel, or if you want to use it in a separate channel. So use channel when the entire transaction and the ledger must be kept confidential. Okay, within a set of organizations that are member of the channel. But collection when transaction and ledger must be shared among a set of organizations, but only a subset of those organizations. Okay, so only subset of those organizations, that time you should use the collection. Clear?
Yes.
So that's it we have for this particular session. Okay, so I hope that that is clear. And you have any questions?
Overall,
Yeah.
overall, no query. That's it, I would say. Let's just looking for to get started practically, because at that time we'll definitely have more and more queries.
Correct. So let me, this is our last theory session. Okay.
Yeah.
We'll discuss about the transaction life cycle also, and then we'll jump into the practical part.
Okay.
So
Yes.
here we'll discuss about the transaction life cycle. Okay, so transaction life cycle is pretty much it is clear, but I will just explain you with a simple diagram, so that it will be very clear to you. Okay, so the very first thing is proposal. So you have the client here, client A, your mobile application, consider as a mobile application. You are sending request to SDK. SDK will create a proposal, it will send to the peers. Okay. After that, your peers, these are the peers, endorsement peers. Okay, these are the endorsement peers. So here the endorsement will be happening. They will provide the endorsement, they will sign the transactions, read and write set, they will send back to the as a signed proposal responses to the SDK. This is the SDK. Then submit. Your SDK will submit those transactions, that transaction on the channel to the ordering services. Ordering services will order those transactions, and then once the ordering is done, it creates the block
After that, those blocks will be going to the peers for the commitment. Here the validation will happen. Once the validation is done, it is submitted or it will committed to the ledger. Once it is updated or committed to the ledger, your client will get the notification your transaction was successful. This is the transaction ID. So this is the life cycle of your simple transaction or the transaction which is happening on the normal transaction which is happening on the channel. Clear?
Yes.
This is the complete life cycle if you want to check it out in the single image. So just look at here. Let me know if you don't understand anything or any point which you don't understand. Just go number wise 1, 2, 3, 4, 5. What is happening in these steps? So in the first step, so first instance you have the client C. The first line is client C. Then endorsing peer EP1, endorsing peer EP2, endorsing peer EP3. 3 endorsing peers. Then orders and then one committing peer, that is CP1. Now your client will send a transaction proposal to all the endorsing peer EP1, EP2, EP3 in the step number 1. In step number 2, they will simulate the transaction, provide the read and write set with the endorsement to the client again. Then your client will going to send the data to the to your ordering services. Then ordering service will create the block and then it will broadcast to the all the peers EP1, EP2, EP3 and CP1. So all will verify if read and write set is okay. If read set is okay, it will apply to the state. Block will be committed to the blockchain. Simple.
Okay. So response that each of endorsing peer will be returned. Would there be any identifier to understand it is about the same request that we made?
Yes, yes. So complete proposal will have the read and write set, right? Read set meaning the current state, as well as the signature of the person who has endorsed that transaction. Okay. So see, the main game here is with the signatures. Every activity, every transaction which is happening will be done, will be signed by a particular person who is doing that task. Okay, and that is the key in the Hyperledger Fabric. So everything will be managed or will be authenticated with the help of signatures. And all the security will come with that signature. Okay.
Yes. Yes.
Now, the main thing here is, okay, we have seen the transaction life cycle in the normal transactions, right? Now, if I apply the private data on the transaction, then how your life cycle will be changed. Okay. So as you know, like if you are using the private data collection, your data is not going to order also. Okay. Your order also will not see your actual data. In normal transactions, your order will see the actual data. Okay, what data you are transferring or what data you are giving in the particular transaction. Okay. But in the private data collection, your order will not be able to see the data. Okay. So let me explain you what is happening in the private data. So normal transaction flow, it is clear, right? It will go to SDK to endorsement. Endorser will send back to the SDK to the order to the commitment, right? That is the process in the normal transaction. Now in the private data, what will happen is from client, it will come to the transaction proposal, come to the org1 peers, okay, who are part of the private data. Okay, so this is an endorsement peer. So in the private data collection also we mention the endorsement policy, like who is going to endorse a private data transaction. Okay, so it will come here, it will simulate the transaction. So first it will simulate inside his transaction, and then directly from the endorsement it will go for the commitment to the peers who are part of the private data. Directly from the endorsement it will go to the it will go for the commitment. You can see the difference, right? In
Yes,
normal
yes.
transaction, it was going from endorsement to like SDK, and then it will go to the order.
Order.
Then it will go for the commitment, right? Here, the actual data will directly go from the endorsement to the committing peer who are part of the private data. Okay, but the hash of the data. So here this peer will create a hash of the data. That hash of the data will go again to the client. Then a transaction submission will be there. Then it will come to the order. Then order will create a block, put that hash inside the block as a transaction, and then it will distribute it to everyone to update the channel state. Okay, I have closed that, right? So channel state and private state, if you guys remember, let me open again that. So two type of states are there in the world state: channel state and private state, if you recall. So 1 minute. Here, so this is my channel state, this is my private state. So if you see on step number 3 here, the private state would be updated. Okay, but when the channel state would be updated, when the hash, when the order will create complete transaction, and then it will allow, like it will send that transaction inside the block, the hashed one, and then this channel state would be updated here after this 4, 5, and 6 and 7.
Yeah.
Okay, so this is how the life cycle will be different in the private data. Okay, only this difference is there. Rest things are pretty much same.
So yeah, that's it we have for the theory. Next, we are going to understand.
One thing I just so tomorrow, if you can ready with the okay. So what you want to do, right? First, will it start with the network or will it start with the go line? Like how you want.
Go line will be better, sir.
Yeah, I think
Because right now we are not going to do the chain code development. So if you want, like when we do the chain code development, just before that, if you want to do the go line.
Yeah, that will work in that way. If
That
you're
is
not going
also-
to do chain code development, then it will make sense
so
to see that once
for
we
next
start.
next at least three sessions, or we are not going to do chain code development.
Okay.
So after that we can have the go line. So it will be like the fresh learning will be there, and fresh you can develop the chain code also, or write the chain code also. Okay, fine then. So that's it I have. Any questions? Anything?
No, nothing as such, right, team?
No, sir.
We will go through these session as we are recording this. So if there are any queries, questions, we can discuss that.
Yeah, so I will give you the access to this. I will upload all the
the
PPTs
documents,
also.
slides. Yeah.
So you can just revise
Yes, definitely.
as you need. Okay.
Yeah. You can
Okay,
update
so-
it on Trello.
Trello, I will give the all the links.
Sure. Thanks for that.
Okay. Yep. Thank you. Thanks everyone.
Thanks for your time. Thanks. Bye.
Bye.
Have a good day.
Thank
Bye.
you.